Okay, so last time we got a rainbow triangle working, cleaned up the build script, ported the other examples of stuff we had done to our new system. And so today I want to now get textures working. So our Julius hat, fractal, rainbow triangle, blinking thing, all on the internet, basically all tidied up. I still need to tidy up a couple of stuff in this repo, but the next step in order to get us closer to porting from scratch, our sliding puzzle game, this one, is to get some textures working. I'm just waiting for GitHub to load the GIF. But yeah, once we've got, like, the fact that this rainbow triangle is working means that we've got shaders that are also passing a bunch of data around. So we can certainly now export the background shader, and like almost porting the texture shader. Once we figure that out, the port will be straightforward. So I think today I want to just create an example here that's just like a texture, and there's a lot of things we could do. Since this is in Zig, I feel like we could do something with the Zig logo, actually. It could be something where we almost have a screensaver like thing where the Zig logo is bouncing around the screen. That would be really easy to implement. That would just be like a bunch of if statements. But yeah, that's the kind of starting point. So why don't we then go like hunting for some of these textures then? If we search the Zig logos, seems like I visited here before. So these are licensed under. These are not complete. These are not public domain. We can also just stick to images that are in the public domain. Why don't we do that? I like space, so we can do something space right. So if we go to Commons, we can just browse some like featured pictures here, or at least stuff that is. Let's say we search planet. Like, so much of NASA's stuff is just public domain, which is incredible. No restriction. We know so little about Neptune. Maybe in my lifetime I'll see a mission that actually goes and learn something about it. It's like, it takes so long for any spacecraft to get there, let alone for it to be studied. Or we could do something with the moon instead. So we have the Voyager 2 image of Neptune, or Planet Fitness. Oh, actually, we should do Pluto. you know, easily one of like the top 10 most important images of the 2010s. Easily defendable as the most important image of the 2010s. Yeah, let's do this. Okay. like all of these names to things that have been given are due to this photo alone. If it wasn't for this photo, we wouldn't know like the names of any of these things. Like there wouldn't have. Yeah, this is so good. Oh wow, like these are. So much has already like been studied, really. Like the vast, like basically everything on this page is like has only been created in like the last decade, but will be around for centuries, well, for the rest of the time. Okay. Yeah, which version should we download? So let's see, if we want to just do something like, I don't want the example to be like, I don't want the WASM to be like unnecessarily large. I reckon we could go with 480 by 480. So let's put this in WASM examples. Let's give this an accurate name to reflect what it is. We'll call it Pluto to begin with, and then we'll give it a better description. I guess we can call this New Horizons Pluto. 'Rather like Pluto, New Horizons. This was a JPEG, right? Yeah. We'll want to convert it though. Like how big is it? Oh, we don't want to. $50 kilobytes, yeah, that's fine. So if we convert with image magic from a New Horizons to a QI. Oh, okay. It was a JPEG, so the size has gone up considerably, but I think 1/3 of a meg is still fine. So let's remove the JPEG. Why did I do that? Remove the JPEG. And let's just add in like a link as well for where we're getting this from. Well, we can add a link in the actual file itself. So let's create another example to make. So we can call this we've given all of these names. I could call this dwarf planet. Dwarf planet. And then dwarf planet. Okay, and then we'll call this main.zig. So in this case here, we might as well use our base rainbow triangle as a thing with which to modify. Example of how saying how to render is like implying there's only one way. Well, an example of rendering a texture in WebGL without having to use the JS code. We should insert. Okay, there's a bunch of stuff to clean up across all of these projects. Let's just do it as we go along. So with our WASM examples, we want to include this URL in the source, and then we finally want to denote where the image came from. The image of Pluto, of the dwarf planet Pluto that is rendered, was taken by the New Horizons. Is the mission or the spacecraft or both called New Horizons? Possibly both the spacecraft and the missions. Okay, New Horizons space probe. We can just say should we say the exact date it was taken on? Doesn't hurt. On 14th of July 2015, and is in the public domain, freely available at let's get the weird that it's like Pluto color text file.jpg, but I guess that's maybe that's like what the file was sent over as before it was turned into image. Okay. So yeah, so before we actually get started on this, there's a couple of other things I want to tidy. So for one, this the URL we just added we need to add that to the other files. So if we go to our rainbow triangle example, we can insert this here. It also occurred to me the other night that even though all of these are things that the compiler doesn't know, and in most cases people just query the canvas object, whatever it is for them. Like the canvas object has still been implemented by whoever was working on the browser, and so there's probably a standard for it, and so we could probably actually just look up the standard itself and then replace all of that with the actual numbers that like the numbers that are encoded, like a bunch of numbers have been encoded in the web browser from some standard. We may as well look those up so we can just encode them into the WASM binary ourselves and then don't ever need to look them up. Like instead of like taking, I don't know how many CPU cycles it would take, like 1,000 cycles to query via the JavaScript method what it is, we can just embed the number in the binary itself, and then it takes like 1 CPU cycle to look up. So yeah, so if we go to WebGL standard, maybe we already have this as a PDF, like Drake. We can do we can look it up in here. No, we're actually going to want the ES specification. Okay, we downloaded the ES specification, but we didn't download the WebGL specification. At least version 1.10 of it. Yeah, I think. Yeah, I think this is what we want. So we should just be able to look up all of these values in this file. So okay, if we check out, say, like what's like a specific one that pointed here many times? Maybe a color buff a bit. Okay, here it is. The WebGL context represents. Maybe we need to make this full screen. Or not. Represents the API allowing, this stuff. So let's just try replacing these and check that it works, but we should be able to, unless there's more like color buff a bit in this document. Where's the F3 button? No, that's it. That's the only instance of it. We'll keep it here. Make this a constant. Now we're saying this is equal to this. And then the other place where we query this from, we should just be able to comment it out now. And so likewise, and a really sure way to check this is working would be to replace the vertex shader stuff. Control F. Hello, why can't I control F? Fragment. Okay, is this still the same area? Yeah. Okay, so we can try compiling this version. So we want to do zig build rainbow triangle. Why is this so slow? We know why it's slow, it's because it's Windows. CD array, CD zig out, rainbow triangle. Okay, it's finished building. Python M HTTP. Get rid of the PDF since we don't need it. Load this again. Okay, yeah, this is still working. Again, since it's still super unclear when exactly Firefox will like refresh the case, etc. Let's just change the background of this, just so we can make it clear that we have obtained something different. Let's make the background super green. Uh-oh, the background is not super green. Okay. The shader is still clearly compiled. So let's go ahead and continue to replace all of these other constants with these things then. And then we'll be able to just like use these across, copy them across all projects. So yeah, okay. Before we do this, we should see where we got these from. WebGL constants obtained from the WebGL specification at I like know where most of the keys on the keyboard are, like intuitively, except for these like F5, F6 keys, and so I like need to I'm always looking them up. I always need to physically look at the keyboard to see where they are. Okay. Let's check out float. This float's going to be everywhere. Color buffer bit. What even? Maybe from here we can. Oh, data type float. 1406. Let's replace all of the. Array buffer. Oh, that looked like it. Static draw. Triangles. What was like the weird, like it's gonna be in here. Okay, this is what we want, not triangle strip, just triangles. It's kind of, I find it a bit bizarre that like this, the color buffer bit is like presented as, when it's presented it has all of these like zeros at the front, but then and it is a GL enum, but then everything else is not. Like, is there something wrong with the specification? Let's just change this to 4,000. While the order here seems intuitive to me, part of me feels that having this in the same order as what's in the documentation would be better. Maybe. We'll go on with it. We'll continue. Done that, and then finally this compile status. 8B81. And then link status. Link status. Okay. Okay. Let's compile again. Oh, forgot to. We can basically get rid of this entire thing now, which is great. Some people think that, like, you know, the best way to measure productivity of programmers is how many lines of code. It's the opposite. It's how many lines of code are you deleting. That is the best measurement. Okay. Cool. It's working. Binary's now smaller. Not that it's actually noticeable. The program's running faster. Not that it's actually noticeable either. But we know in the background. But the lines of code is significantly shorter. So let's get rid of all of this. Anything else we can get rid of? I think that was it. Okay, so if we go to, let's see, if we do git status, what's changed? Let's say our rainbow triangle changes first. Removed or like replaced WebGL context constant lookups with the actual like constants per the specification. Okay, now we should be able to add the rest, except for these like silly dash sign things. Git ignore. I thought we already had that in there. Apparently not. added more files to. Okay, now I think we can finally add. We'll add the Pluto. Added Pluto image. We will get around to doing that, but we can now add these to the rest of the projects. So for the blinking screen example, which also needs us to do this, rainbow triangle. Oh, there's a bunch of stuff, of commented stuff in here we can probably delete and clean up from the file anyway. Okay, it was actually good we're revisiting this and doing this. Okay, so what constants were we actually using? Only the color buffer bit, alright. Good to know. So, that can go, these can go, yeah, all that can go. Let's just use the same, comment we used up here. And then when we actually look this up, well, we can entirely get rid of get GL constants. All of the shaders can go. Whoa, so much stuff. So much stuff to delete. The example is still slightly over 100. For now, 112, yeah, that's alright. Okay, zig build blinking. Let's clear out everything. Remove cache. Something's off with my keyboard position today. Not good. Zig build blinking screen. So give this a go. Clear this. Okay. It's working. Cool. Finally, let's replace everything in the fractal example. So we want to check out a color buffer bit. So I guess we're using all of these as well. Certainly all of these would be the same, and then yeah, we're drawing it in the same way. So for the compile status, all of this stuff can go. Get GL constants. Zig remove zig out, zig build, looping, fractal, done. It's more everyone's favorite Firefox case issue. Okay, that's working. We can move on. It is fun to look at though. We might keep it here. Oh, we need to add in this as well. Both libraries have MIT licenses. Why both? Zig JavaScript Bridge does. It does have a MIT license, right? See the source. Dependency. See the link. Dependency for more details. Let's save this as like M to MIT. Okay, anything else to clean up here? Okay, so did we update all of these? Yeah, replace to do with that. Added that in. Replaced all of that, simplified all of that. And so here we're saying more GL context, more WebGL context. Manually specified in binary. Okay. Ooh, I'm kind of feeling a bit dehydrated. I should get some water. Why not? Small break. Small break. I'll leave this to play. But yeah, I will be back. Okay. Alright. It's weird that like some of these frames are dropping, but I guess it's alright now. Okay, so now stuff has been cleaned up. We can begin to work on the on rendering Pluto on the web. So where to begin? Why is this open? Don't need that, I think, either. So yeah, so let's just copy in again. Put it dwarf planet anyway. Yeah, we've opened a bajillion files. Let's launch everything again. Let's copy in the rainbow triangle example from main into the dwarf planet. Open up, run Emacs dwarf planet main. There's all of these like crappy artifacts come from everywhere. Okay, how do an example of rendering a texture in WebGL. Let's just replace all instances of rainbow triangle with draw full animate. Okay. Yeah, so what are we going to have to do here? We're going to... Let's check out the sliding puzzle code, since now we like figured out like the stuff about specifying the location of the attributes before the linker and all of that stuff. We should be able to kind of just modify this, and with the relevant texture calls get stuff working. So let's go to what's it, sliding puzzle. Yeah, it just would have been in main. So if you go to, okay. Oh, this with a lot of stuff's going to go on here. So the first thing we need to do is get the start decoding into pixels our image file at runtime, kind of like number one, and then we won't have to do, well, we won't have to do this stuff in this case. When we're setting up the array buffers though, okay, set up blue marble texture. So here we go. Here's where we say, yeah, like we already assigned this based on in the data, so we're just setting it there. This is the case where it's like it's done slightly differently. Like the location is returned to us in the WASM, but we'll just save it locally as well. Right, the return, like in OpenGL, this is like a void function, but in WebGL it returns the location, and then the number, and then we'll need to add in texture 2D to our constant list. Oh, there's a lot of extra constants we're gonna have to add in. It's okay. That stuff will be the same. And then hopefully this, I have a feeling that this is going to be slightly different in WebGL, but hopefully it doesn't differ that much. Binding the texture, we'll see. Oh, there's gonna be a lot of stuff to look up, but again, we just do it once, and then we can render any damn texture we want. So It's worth it. We'll get there. Okay, and then once we've actually got that, then oh, actually, it's not as bad as I thought it was. Like, this is basically a repeat of what was there above. Okay, so it's just that. This is really manageable. Let's save it and then we can copy it. Okay, and then when we actually want to use this, what are we going to have to do? Okay, let's just go back to the main. So, I reckon after we've initted the clock, this is when we can decompress. It's really just a single image, but yeah, decompress the image. And we may as well just do that now. Decompress image. Like, I'm so happy that I guess it was like this time last year we like manually wrote our own QOI image decoder. Like, it's so good just to be able to just add in the code in the way we want it without having to call an extra lib in. It's like a single file as well. It's good. But before that, we want to, at comp time, pass the header stuff. So we're going to have to rename all of this as well. So we'll replace blue marble with, I guess, Pluto. Well, Pluto New Horizons would be better, but everyone knows it's going to be Pluto. And then okay. Yeah, let's have an image section up here as well. I guess after the timestamp, or rather like image. So yeah, what? Like, surely the image of Pluto has its like. It has it as like a name, as like canonical as like the blue marble. But maybe since this is like 2015 and like Carl Sagan correctly predicted, people these days don't demonstrate an awareness or care for science like they used to. Maybe the media coverage this got wasn't that significant, and despite the obvious huge achievement of this. So maybe it hasn't been given a name by the people. Pluto 01 Stern 03 Pluto color. There is more spam. The spam comes every stream. Every stream. I'm starting to remember where all the buttons are. this has to be given. This has to be given a name. Maybe we just describe what it is. So we can say here, yeah, the photo of, of Pluto below. I guess we somewhat, I guess we like overrode it, oops. Yeah, the photo of Pluto below, yeah, was taken by the New Horizons spacecraft. Was it July? Was it 15th of July 2015? Oops, 14th of July. This is the first time we've completed this. I guess maybe there's no. Is there a need to repeat it? Oh, kind of weird that we didn't include it at the top here. I feel like duplicating it is unnecessary, but I feel like it's better to have. Is it better to have this at the top or? I feel like it's better to have it at the top and then to reference it here. See the header of this file for more information. Okay. Okay. So now we want to put this in, I don't think there's any need to create a subdirectory in this case. I think we can just put it in here. Pluto New Horizons. We'll keep that. Pluto. We should probably move this to an underscore. Pluto New Horizons. Okay. Stuff's done. So now I can actually get on with. Well, let's like check that this compiles and still kind of works. So if we go to Emacs, what are you doing? If we go to decompress image, and here we just like print out some information about it. It doesn't really matter what. You could say console dot how would we log stuff with this again? Log string. Log. I suppose we can log in. Well. How could we do a like format print string here? We're just checking this works. We don't need to do anything unnecessary. So let's just say we log, it takes any type. So we can take in like Pluto width, and then let's say we log the Pluto height as well. Okay. Well, there's like so much stuff needs to be done just to make another example. But we're doing it. Okay, so we want to make a custom out directory, so we can make this dwarf planet. Likewise, rainbow triangle with dwarf planet. Oh, are we gonna have to copy in the source stuff? Yeah. So let's copy the rainbow triangle static into dwarf planet. The static's now in there. We're gonna have to change a bit of that though, and then build option wise. Do the same things. Then when we are generating these paths, that's the same, we don't need to touch it. For the rainbow triangle step, we want to make one for the for that. We should be aligning these. Like, doing this amount of copying is making me thinking, like, we need to re-simplify the build file yet again. We'll do that later. Let's just focus on adding another project. Okay, I think that's all that's needed on the build script side. Since we just copied in a bunch of static stuff, it would be wise and necessary to modify that stuff over here as well. So here we can call the title like dwarf planet Pluto example. Script wise, placing this with dwarf planet And then that's it. So let's try and build this example now. Not expecting to see anything aside from the size of the stuff on its compiler. On the screen. 78. Index 3 out of, the build script. That's right. Oh yeah, we're gonna have to actually import the QI stuff. So I think we can say const QI is equal to import QI.zig, and then we can just copy this in the same way that we did in the sliding puzzle case. So here there should just be like a QI file. Oh, I guess here it's in dependencies. So here documents, zig, WebGL, WASM, dwarf planet there. Yeah, I forgot to move back. File not found QI.zig. I literally just moved it in here. Why does it think it went? How can this possibly not find QI.zig? It's here. Maybe, like we are, what? Oh wait, this is in build.zig, oops. We want to go to main.zig. Okay, that makes sense. Use of underclad identifier color. Okay. Sliding puzzle main. Where should we put this? I guess we can put it here. Alias. Oh, really doesn't like this. Not finding the vertex shader, which makes sense, since we didn't copy that either. Can I do like star.glsl and copy all of those to dwarf planet? Will that work? Seems to have worked. Oh, okay, now we're getting some serious, an actual problem. Reached unreachable code. Why? Let's just clear the cache as always. Unexpected type use32. Oh, okay. But what's the line that's triggering this? Oh, it must have been in like the log function. Okay. Fine. I guess like the struct of qi.zig in the the image hide is of both u32s. Okay. So we'll just int cast this as an i32. And I've forgotten another parentheses. Okay, but otherwise it built. So now there is a dwarf planet. So now we can do Python mcp server. Let's create another window. So yeah, not expecting much to render. Actually, I kind of was, we are expecting this, but 480. Oh, it's saying both the 480. Oh, we did download 480 by 480, great. Okay. So the QI is working. The pixels have been made. So now we can go on to the hard part of the WebGL calls to make this a texture. So, yeah, we've got Pluto pixel bytes as the thing we'll need to call. Yeah. So in setup array buffers, this is where we'll want to do our texture stuff. I'm gonna have to redo this. Redo that. Yeah, like a huge amount of this needs to be. Okay, what are we gonna do? We're gonna just pass in the coordinates where we want the triangles that will render the textures to be, which will just be like top left, top right, like the same as in the fractal example. So we can just copy that stuff in straight away. But then we're going to have to add in additional coordinates with which to display the textures. So in the looping fractal example, when we go to like the GPU data, also why is this comment an RGB triangle? It's clearly not. Define a yeah, let's just immediately change this. Well, okay, it kind of is the triangle GPU data. Let's So we want it to be in that form. So yeah, the y pos, the x pos, the y pos, and then we want like the x texture, the y texture coordinate, coordinate, maybe just x texture, y texture. So I feel like, okay, when we did this for the sliding puzzle game, the first time we tried replicating it and then we got weird results because some of them were meant to be 0 and 1 instead. We can check out what they actually were again. So for the sliding puzzle game, where is the stuff? Oh, I don't see a structure with the coordinates. I guess we did something more sophisticated than what was in my head. Did we set this in the render? Oh, there's this whole like geo uniform I1. Oh, that's right. You have to say the texture location. I think it was these coordinates that we were passing in. So 0, 0, and 1, 1. Okay, so if we say the bottom left is 0, 0 and the top right is 1, 1, then basically like we're copying the same numbers here, but if it's a 1, it's a 1, but if it's a negative 1, it converts to a 0. So this should then be 1, 1, 0, 1, 1, 0, 0, 1, 1, 0, 0, 0. And again, all of these have been mocked up because of Emacs and Zig formatting. Okay, and now we've got 6 rows of 4 floats each. Okay, we're gonna also have to, of course, adjust the shaders to include this stuff. Oh, there's like so much work to get just a single texture on the screen without sweeping it under the rug. Everyone else who's making a game is sweeping all of this stuff. It's going, let someone else take care of it. No, we will take care of it ourselves here. Okay, so we got this. So let's just check out the sliding puzzle shaders. Oh, we had like a fairly complicated shader, which I guess is okay. We'll be able to simplify it. So the current one is this, the old one is this. So we're keeping the version here, but what are we adding in? We have an attribute of a pos, and then like an a texture and a texture coordinate. That itself will have to link and choose the position of. So where's the APOS? Yeah, in this part here where instead of binding the A color as the second position, we want a tech coord to be that. Are we passing any float into the texture coordinate? No. And then actually, I guess for the yeah, we'll just we don't need this. We've already done our own version of the WebGL version of these things. We're gonna have to set like the varying to be what we want the tech coordinate to be. But otherwise, we could just copy this. So let's see. I think all of that stuff can go. Okay, so we want to have a varying here. So yet again, I guess I must have just deleted it. But if we go to the rainbow triangle vertex shader, we just simply say varying, and then what we want to pass on. In this case, is the tech coord. That then covers that line. Oh, do we need to do any normalization stuff? Like, I think I was slightly surprised in the previous version when we up until now where like everything has worked with us without having to do specific normalization. I think in this case, since we're still specifying the coordinates to be between -1 and 1 and 0 and 1, it should be okay. We shouldn't need to do anything like this. I think we can just do this. Keep the uniform float time there. Okay. Oh, what's the time? 6. I should. Kind of want to go swimming soon. Actually, I've done enough. I've done a fair bit of exercise today. Let's get this working instead. We'll continue. So, we've changed these parts of the shader, so now we want to change the fragment shader. And let's see, in our puzzle, was it not called puzzle in our sliding puzzle? What did our shader look like? It looked like this. So, so we say varying for the thing that we're passing in. So in this case, it's the tech coordinate. It's the 2. Why was there a precision medium float here? Like, does this need to be present in everything? Anyway, so we're doing a couple things. We got this texture color by doing a uniform. Let's check if this is in the WebGL specification. Hopefully it is. Sampler 2D. I mean, it's here, so at least some version of it should be. Those are the only 2 cases sampler appears. Oh, but this isn't the shading language. Okay, it's in there, it's fine. Okay, and then it looks like we still kind of want geo underscore frag color is equal to so here we don't want the interpolated color, we just want the texture color. Okay. And then there's our fragment shader for the texture. Okay. We should just like probably save what we've done so far, even though it won't work, but which is fine. We're in the middle of making it. Zig build dwarf planet. Okay. Oh, how is stuff differing? Oh, we forgot to save this. Oops. Lots of stuff in this commit. Okay, we want to basically add in everything in dwarf planet. We want to basically add in everything. Started making dwarf planet example, tidying, other examples. Okay. Let's get that to GitHub as it is, and then back to the main code. So I think we're now at the stage where we have to okay, we need to specify the array attributes. So all of these numbers are going to change. So in index 2 we've got 2 floats, the stride is 4 and the offset is 0. In the second case we've got 2 floats, the stride is also 4, however the offset's now 2. Okay, that should be that part done. Okay, maybe before we do anything with the uniforms and like adjust what the we could do something fun with the fragment shader, but for now we'll just keep it plain. Okay, we've described for the data we're sending how to get it into the shaders. We now need to describe the texture data and then get that into the shaders as well. Okay, so now it's back to the sliding puzzle example, in particular for the texture stuff. Blue marble. Okay, so let's save it as a global. The color vertex shader program is here going to change to just like texture shader. Now it's Pluto shader. Texture, it's not gonna like, so we can just say C int, or rather just I32. Okay, here's the stuff. Now we want to set up Pluto texture. So maybe we can just get away with copying in, replacing blue marble with Pluto in every situation. That line, like mentioned earlier, we are going to have to adjust. I'm going to have to look up all of this. It's getting dark. Can wait another 10 minutes before turning the light on. So yeah, the gen textures, this is going to change. Gen textures. Well, actually, it's actually saying it's kind of the same. All right, that's busted. We'll look up Mozilla's documentation. WebGL, GLGen, gen textures. What do we like with regards to frame? Oh, we're massively dropping. Why? We've already looked this up before. What, like, do I need to know how to load it? Like, Zeke's doing this competently. So here it's saying like create texture instead of gen texture. Why? So, okay, so for tech image 2D, texture 2D level internal format, whatever that is. Okay, it has been specified. The width and the height, the border, source format, yeah, source type unsigned byte, and then hopefully we can still just pass a pointer to this. Oh, it's getting so dark. Okay, well, that's fine, but what about these parameters? Okay, this is basically the same. Great. But we don't want to be generating any maps. What about bind texture? Is disappearing at all? Okay. So Mozilla gl.gen textures. No, I want like so maybe gen texture has been I want to say like replaced with create texture, but then like it's here. So okay. I guess it has been replaced with it. Yeah, if the only place it's appearing is in reference to create texture. Okay, and yeah, like I predicted, it is returning something. It's not a void. I think. Yeah. Okay, so okay, so where does that leave us then? So is it create? It's create texture. Okay. So we want to say something is equal to geo dot. Basically, we'd be calling geo create texture. So we'll need to like convert that. And what exactly is it going to be passing? Surely the WebGL texture is just a I32. Or is it like a handle? Okay, let's turn the light on. And then, yeah, what is this going to be? Like, I suspect this is... have there been other calls to other create stuff? So in the rainbow triangle example, did we have to do create? Okay, so it's we might just go with like the ZJB handle as like the return type. And that when we were creating the shader, that was what it was. And the create program feels like, yeah, this is creating some WebGL program object, and then in our case, we don't need the sliding puzzle anymore, I guess. There's so much stuff Emacs, what are you doing? Stop it. Just quit everything. Stop it. Run it. Okay. You want to do just the dwarf planet main. Too many things open. Way too many things open. We only want to be comparing the rainbow triangle main example with the current one. So, yeah, we're turning these handles for create, shader, and then in the dwarf planet, we're saying create texture. Yeah, so I reckon we should just, this should be like the ZJB handle thing. Okay, so in that case, the texture, the Pluto texture is actually ZJB.handle and undefined. Okay, this makes sense since everything else is ZJB handle. Okay, we're there now. So Pluto texture is equal to that thing. So if we want to convert this, we'll convert all of these things later. Okay, then onto the bind texture, if that is what it is. Yeah, this is a void, and from the Mozilla documentation it looked like this behaves in the same way, right? Yeah, but okay, before we do any of that, there's a bunch of constants we'll need to copy in. Let's put it horizontally. GL underscore stuff. So what do we got? So much. GL texture 2D. Texture wrap S, texture wrap T, texture warp, wrap S. There's a potential poetry line in that. Wrap T, clamp to border, texture min filter, texture. So why am I writing this in? We're using Emacs. We can convert everything. Texture mag filter nearest. GL underscore. Okay. I think that's all. There may be even more, but for the moment. Const stuff. Okay. Now we need to look these up. Emacs, stop it. Texture 2D. Let's just define a macro. And backspace I32. Okay, and now we can say equal something with that. Texture wrap s is what? $28.02, and this one's $28.03. Then clamp to there's no clamp to border. What's this version in GL? So we have clamp to edge. Is there in the OpenGL book? Is there something known as clamp to edge? There is. Oh, okay. So I guess there's simply no. We don't have clamp to border. I mean, that's fine. I guess we'll just have to use clamp to edge, but that's so weird that this was dropped. Yeah, it's just it. I was like talking to someone a while ago, and they're like, "Oh, like converting stuff from WebGL to OpenGL is like super easy. It's like an hour max." And I'm just like, you don't know what you're talking. It sounds like you don't know what you're talking about. I doubt you've ever done this. There's like, in like the smallest places, weird differences arise, and then this is one example of this, where like, yeah, we've got repeat, clamp to edge, and mirrored repeat, but no, we're just going to completely drop clamp to border. It's like, okay, all right, that's how it is, I guess. So let's change then clamp to border, clamp to edge, and that will be that value. Okay, texture min filter we do have. As well as the mag, so we'll just keep it in the same order as in here. 2800 and then 2801. And then nearest. Nearest, okay. Good, that I would be appalled if this was dropped and everyone was stuck with linear. Okay. Okay, all of those constants in. This is so much work. So then we can go back into this world. So we'll come back to the bind for texture part. But for now, let's replicate this stuff and convert it. So all of our, can basically replace some of these dots with underscores. Yes, 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 no, yes, 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 no, yes, 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 no, yes, yes, yes. Okay. Then so GL tech parameter, tech parameter get text parameter. Well, aren't we setting this? Let's take parameter I. I guess all of these are take parameter. Okay. Take parameter I. Yeah, it's a void, and then we're just passing in the. Apparently, like 2 of these are in enum, and then the other one is an int because, yeah. Good to know that geonearest is not an enum, and Mag thought it is. Just fast forward to the future when like Zeek is overtaken C, and all of this stuff is just has sensible types. Also a future where there's not a bajillion different specifications for each GPU, and there's like a common shader language for all of them, please. For the moment, we're stuck here. So weird. Anyway, so okay, we need to convert these, we need to call these JavaScript functions from within the WASM. So we can do GL context call, then the string, so text tech parameter I, then the arguments we're passing, which are just going to be these things. Then let's just zoom out again. Then what do we do? We then just specify the type, but this is a void. Okay. So we just do 4 of these calls, and in each time we're just passing in slightly different args. I feel like something's been misaligned somewhere. Oh, that's because of this stuff. Okay. Okay, let's just check those. That's doing the same thing. Oh, was this the case where like the clamp to border doesn't exist, and so we need to like choose something else instead? Yeah. We want to change it to clamp to edge. To border to edge. Okay. We should just have this as a note. The WebGL specification does not define clamp to border. Weird. Okay. those parts are converted. These parts are in zig, so they don't change. And then GL tech image 2D. We're going to have to adjust this as well. Probably. Maybe not. How did we deal with pointers in the rainbow triangle version? Let's see, we had the data on the stack in the data in the WASM, and then on the stack in the WASM, and then then we needed to make like a data view object out of it, and then that was what we passed. Presumably it's just the same thing. So maybe we just check out the Mozilla documentation this time. So much stuff here, let's clear it out. Wait, why is this called like one blah blah blah? Oops. It's not called Pluto, it's now 134340 Pluto. Okay, good to know. This number doesn't seem that memorable. It's like 10 with two 34s in the middle, okay. 134340 Pluto. That's okay. Wait, there's a BTS song called One Third. That's so silly. All right. I don't know. Maybe by listening to the song, it's easy to remember the name. So yeah, we're doing the tech image 2D. I'm getting a phone call. But I'm doing graphics programming at the moment. If I have to estimate when I'll be free, how much longer will this take? Well, we've like done almost everything except there's gonna be bugs. Like it's not gonna. I would be astonished if it works first time. Okay, let's say we're done in like half an hour. That feels like it's not gonna happen, but we'll see. Maybe everything is mainly be done and then there'll be some bugs in half an hour. Okay. Yeah, looking up tech image 2D. Mozilla tech image 2D. No. My friend isn't swimming tonight? What? Okay. Like, this doesn't need to be an overloaded function. Just provide a single version, and then people can just pass in like 0 if they don't need a parameter. So silly. So silly. Okay, so what do we, let's just figure out which one we're gonna have to use. So, yeah, target is just, why is it called target? Like, it's, target's just the enum, and then 0 is level of detail. We're not doing any map stuff, so it's just 0. Then it's, oh, we're gonna have to look this up as well. I was like, oh, we're gonna have to look up unsigned byte as well. We're definitely not finished looking up the values. Oh gosh, so many. What do we got? RGBA and unsigned byte. So const geo underscore and RGBA is the pixel format. And then the unsigned byte is what? Why is this commented out? Does this is this a data type? There's a bunch of values. I see like what? Luminance alpha, luminance, various anagrams of RGBA. Let's just look up some of these. Luminance alpha. Where's this one? Luminance. Okay, it must be this one. But no, we're looking up unsigned byte. Oh, okay. Okay, we want to look up like unsigned short 565. Unsigned. No, it's been commented out. Come on. Don't tell me I like have to query this one instead of inserting it as a constant. This sucks. Unless it's commented out here because it's like already been defined as a constant, which like feels really weird if like these names are being doubled up. Like it appears there. I guess that's why it's been commented out. Especially if up here it's like allowed. A uint8 array must be supplied. Whatever that means. Like, again, what even does the 8 mean? Like, is it? It's so bad. Like, outside of the world of Zig, Odin, and Jai, everything is just like, everything actively wastes your time by being difficult to understand. Okay, let's just, yeah, we'll test this out. Okay. Let's like make a note. This line in the documentation, in the WebGL specification, is commented out, but unsigned. I'm gonna be so pissed if like it doesn't work because of some bug and it's like due to this. I'm gonna be livid. Let's just like add in like possible bug is defined as another. So this is the thing, right? If like C actually had a decent enum, it would be completely possible to just say, yeah, we're gonna like group all of these, like we're gonna group all of these up, give these things like its own enum, it's going to be sort of checked. We won't have to just like duplicate like a it's so bad. But unsigned bind is defined as another constant is commented out in data type, is defined in, where is it? No, wait, it's defined in data type, but it was commented out in pixel type. This is like, so we're using the okay. All right, okay. Hopefully that is the last of that. So, so yeah, unsigned byte, even though it's in a completely different, basically a different enum. And then, this is, yeah. There's a target, okay, yeah, target, internal format. Now it's the width and the height. Okay, wow. In WebGL2, it can be snorm. Wow. Like, how long must it take to have to, like, write, like, the WebGL code to, like, interface with, like, the graphics driver when there's, like, this many options? But also, more importantly, like, are all of these, like, actually used? Like, I feel that, like, maybe, like, 90% of people use, like, 2 or 3 of these, and then everything else is, like, some random thing. Anyway. So yeah, bajillion options. And then, yeah, then we do the width and the height. Then, what's next? Border must be 0. Well, okay. Well, we know why, because it was disabled. The clamp to border was disabled. And then the format which oh, there's like an external table. Okay, but that's the same table above, right? Okay, type. Yeah, we know the story with that, and then okay, it does say it's like okay, but and then the Pluto, and then finally after the type, okay, the pixel, and then it can always be used, whatever, there's some crappy object, and then when we actually specify the height, width, and border, so this is where the thing said like it needed to be the U8 array. So like tech image 2di, where was the like, no, tech parameter. Where's like the warning thing? Whatever, it's, I think this is what this like data view thing did. We should check out the source. Okay, so if we go to, oh, it's gonna, the half an hour, I knew the half an hour was pushing it anyway. Data view, so what's being called here? It's just it's producing some handle, which is producing, yeah, there's this ZJB handle, and we're switching on the type. Okay, we're giving it a pointer, which is fine, otherwise it would compile error anyway. And then if the size is 1, do data view not capitalized. Oh, it's just literally like a pointer and then the size. Okay. At this stage, we have nothing else to go off of. I think. What is this? A U-in-8 array. Okay, 8-bit unsigned integers, i.e. bytes. Why didn't you just call it like? Anyway, okay. Clearly, everything's fine. So, yeah. So then we should just be able to call it as a, well. We need to make this like handle thing. So we want to say image, or like pixel data object is equal to ZJB dot data view, where whatever the Pluto pixel location is called, Pluto pixel bytes. And then I guess we can do that a bit later, actually. oops, 0. And then, oh, kind of weird that we didn't have to pass the 0 above. That is kind of weird. Let's just modify the rainbow triangle example and see if this affects it. Okay. So normally, just saying like that's the first byte, the address of it. That's like the way of guaranteeing it's gonna work. Zig build rainbow triangle. And then zig out rainbow triangle -m http.server. That's loaded in here. We're gonna have to do another clearing the cookies. I mean, clearing the cache. Okay, yeah, this, okay, it looks like it has failed. So I guess we got lucky this time. So yeah, specifying the first byte of it is actually going to fail it, I think. Zig build rainbow triangle. Okay, so you have to be really careful. To not make that a 0. So likewise, if we also have like a fixed array of floats, yeah, we shouldn't, it shouldn't be Pluto textures 0, it should just be bytes 0, it should just be bytes. Okay. Alright. Yeah, so then we want to now do GL context core. Surely this is a void as well. None, okay. Good. Yeah, GL context core tech image, it is tech image 2D, yeah. 2D, GL underscore texture 2D, 0 GL RGBA, yeah, VM width, these should be I32s. Size I, like these names just waste people's time. Like, why is there a separate table for saying like the GL size I is a long? Just call it like an I32. Just so bad. Like the only thing any programmer wants to know is like, is it signed or unsigned, and then how many bits is it? So the name should just reflect that. U32, I8. Like, nothing else is needed. 0 geo RGBA geo unsigned byte, and now the pixel data object. Okay. So I've converted most things now, except for this. Oh, we do need to do this again. Yeah, this is the handle. Geo context core create texture, and then the args, which, well, what are the args? Geo create texture. Yes. Previously, we would pass in the number to make and then a pointer, but now it's different. Oh, I guess it's like, doesn't take in any arguments. Okay. Yeah, no parameters, but the thing. Okay, easy. So jb.handle. Okay, that's converted. We need to convert the bind texture as well. So what's that gonna be? Bind texture. Target and then the WebGL texture. So yeah, basically that. Okay, it's a void. Geo context core bind texture. The enum, then the Pluto texture. Okay. Okay, so that should be that part set up. Let's see if it still compiles. Okay, well, we don't want to build that one. Zig build dwarf planet. Okay, error time. 253. Oh, yep. Missing stuff. Bind texture is a void, yep. Undeclared identifier, color vertex shader program. That is correct, since we renamed it to texture shader program. Color vertex shader, change to texture shader. Remember, function expected 3 arguments, found 10. What? All right, we forgot to wrap this stuff up. What was the return type of tech image 2D image? It's a void. Oh, it's not compiling. Okay, but not going to be rendering probably, since we have to call. There's other stuff we have to do. Well, let's just see. Like, we need to set like the uniform and say like use this texture, but like sometimes the default's to 0, so we could not expecting anything, but let's just see. Python m HTTP server. If anything, this will probably just give us let's clear the cache again. An error telling us something went wrong. Oh, we're not compiling our vertex shader. That is embarrassing. Let's fix that. GL position syntax error. And it doesn't stop there. No precision defined for float. Okay, we do need to have that. No matching over. Let's just start with the first one. Okay, so doesn't like GL position. Why compiled with the rainbow? With the rainbow one. Oh, maybe it's because I didn't specify the precision. Nope, still doesn't like it. So yeah, like, why? Oh, wait, is it? Oh, it's because we don't even have like void main. Embarrassing. Okay. That explains that. That would explain it. Okay, we do need to like specify this precision. But wait, we just did we not? Oh, maybe we need to specify this above the other stuff. But no, we didn't. We didn't here. Let's just try moving it above these attributes then. It may be like more cache crap going on. No, it's what? it's also not liking line 12 for some reason. Yeah, what's going on? But like, also, where's the debug saying that the vertex shader didn't or did compile? Like, oh, maybe we actually fixed the problem and it's now the fragment shader that's failing. That's probably the case. When we have, okay, we should print debugs like, okay, we're printing the debug if the shader linked successfully. Okay, let's see if the fragment shader did compile. Let's just say vertex shader successfully compiled. Okay. Maybe we can actually just get it this time. Okay, it did. Well, it did. It's just, we shouldn't be printing error here, but it was successful. Okay, so yeah, the reason why the float precision wasn't working was because it was fine. But we can probably like get rid of that entirely. Let's see. Yeah, it's fine. Okay, now to the actual issue, which is, should I keep this stuff here? May as well. The fragment shader. Okay, here's the problem. So now we're saying, yeah, no precision specified for float. This is line 5, so maybe it wants this like higher. But we're also getting some dimension mismatch. No. Cannot convert const medium float to 4-component vector line 12. I move stuff around. Let's try it again. So this 480. We don't need that. Okay. Yeah. Let's maybe the best thing to do here is to well, we can first of all check the specification. Oh, wasn't this the thing where like yeah, no, we did have sampler 2D. We're also not doing Vulkan. Sampler 2D. Texture, e.g. 2D, sampler, opaque types. These types are only available when targeting Vulkan. Okay, what do we do then? Let's just check out the. Really? I part of me's just like. I mean, it's here. Let's see what happens here. So what do they do? Okay, so yeah, we've done create texture, we've bound it. And then, because the images have to be downloaded on the internet, that's why I put in the WASM. So it doesn't need to be downloaded anywhere. It's a static website. Like, so bad. So bad. Okay, then here's the thing we actually want, I guess. Okay, but like, there's gonna, where's the shader that's gonna be using this? Right, so, yeah, we set all this stuff, and then, let's just explain what that is, and then, that was just like calling the above code, and then, oh, wait, do we need to do this like pixel store I? I don't remember writing that, but I highly suspect we had to do this in the sliding puzzle. Pixels. Oh, we didn't? Really? Okay. Okay, yeah, then they've done their own, why are there so many coordinates here? What are they doing with all of these? Why is it 8 instead of 4? What are they doing? I guess we'll see in the shader. So, okay. Okay, so they have varying high P vec2 V texture coord. This is still the WebGL API, not the Web2, yeah. Okay, so we can basically just copy this. This is what we want, I think. So we want to say varying high P vec2 tech coord. Then uniform sampler 2D. So here it's like U sampler. What is the U sampler doing? Let's just call it U sampler. Not that it probably makes any difference. And then we still got void main. And yeah, geofrag color. Oh, okay. So this is now texture 2D instead of texture. Texture 2D, U sampler, tech coord. Okay, let's see if this compiles then. If it doesn't, I will be confused. Oh no, no precision specified for float. Line 10. Do I need to do like high P as well? But I thought like it's recommended to use like the low P whenever possible. Okay, well hey, something is drawing on the screen now. Not bad. That was unexpected. I didn't expect that to be drawing on the screen at all. WebGL warnings. Array buffer view type not compatible with type unsigned byte. I knew it. Like I knew this freaking unsigned byte thing was gonna appear. Okay. Okay, so I'm gonna have to think. So the fact that this is black and there's no Pluto is suggesting that I think like with the texture coordinates, you actually don't want them to go from like, you have to like normalize, it's like just choosing like the smallest part of the image, and you actually need to normalize it. So what even, it was 480, wasn't it? So I think if we go into the we go into main, well, there's a lot of things going on. So first of all, it's only drawing one triangle instead of two, but that's because we're only drawing using 3 vertices instead of 6, number one. Okay, and then number 2, if we change the coordinates here to be, okay, we want to replace some of these ones with 480s. No, no, yes, yes, no, no, yes, no, no, yes, no, 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 yes, no, no, yes. Let's try compiling this. Okay. It's still a black. That sucks. The black square. The black square movement. The way to end police brutality is by posting a black square. Not by bajillions of other actions. Okay, let's... how are we going to deal with this? Let's just save what we have so far. Oh wait, this is not the this one here is the adding stuff. So let's yeah, we can say got shaders compiling, but the texture not rendering yet. Okay, get that up. So yeah, how are we gonna deal with this? Max typed array view type not compatible with unsigned byte. There was a reason it was commented out. But were we not supplying a uint8 array? Let's see, unsigned byte. the other option is that is it the case that when we convert it to the QI, I think I checked this before once, but it was like, is the QI okay with the RG? Like, is there actually an alpha channel? I guess this is something we can just check directly, right? If we open up the Pluto QI, and then we do hex mode, yeah, we're gonna have to look at the specification again. Why am I using default Windows search? There is a better option. File pilot. We want to do documents, PDF. I didn't put it in there. There it is. Well, we put it in software. It's not a good place to have it. Let's move it to. We had like a place for specifications, didn't we? I could have sworn we did. Well, we can find it. Oh, we put it inside cheat sheets. I guess that's a better place for it to go. Okay, so back to the bytes. That could be a catchphrase. So yeah, the first is just the thing, and then the color space is what we want to know. So yeah, bytes, and then the width, the height, the channels, why isn't it like the lowest bit set? Why is it like 3? Oh, oops. Yeah, 0. RGB with all linear alpha. Oh no, yeah, this is busted. This is meant to be a 4, but instead it's just a 3 here. Okay, that does explain it. So okay, not good. So now we need to convert okay, even if this was the case, I would expect at least the image data to have something like really weird, not just be completely black. But maybe there's like some alignment issue, and then that would also explain why it was weird. Okay, so that's a thing, but again, I'm still like slightly surprised. So when we did the sliding puzzle example, we did the same steps in that, and that rendered, and well, did we not use RGBA for that? Yeah, we did, and if we went into the assets for that and looked at the blue marble, oh, this truly, no, it's a 3 again, so Yeah, so it should be something else. Oh, but okay, I remember now why. I think it's because like the A value is always like 255 maybe. How's this working? Maybe it's like it's still always 4 bytes per pixel, and it just automatically makes the last one 255, or it can vary. Is that how it works? Oh, but okay, again, okay, again, it shouldn't matter because in our decoder, we already convert everything to these 4 byte pixels anyway. So, okay, down the wrong rabbit hole, I guess. Let's just clear out everything. Too many things. Run Emacs. Dwarf planet. Okay, so where do we go then? If we check out the Pluto stuff again. What is this error message saying? A rougher array buffer view type not compatible. But again, we weren't expecting this to work anyway, so I think we should just read through like the rest of adjust the rest of the stuff, and then come back to it. But it's at least compiling. So. Okay, so in the sliding puzzle example, when we actually wanted to use the texture, how did this stuff work? Yeah, so we use this one. Wow. Oh, wait, is that it? Yeah, we like set the texture here, and then do we not call it again? Yeah, make the texture active. We should do this. So, so in render, this isn't, yeah, in the render, we want to, oh, there's also like the uniform stuff as well. Yeah, save that to copy. But that was kind of it, and we don't need to do the buffer subdata since we've already pushed it. I think so. So what are how many rates are we dropping? Oh, we've massively dropped. Sucks. Why is it so low? Was it this? Anyway, so there's that, but we could also check the this like tutorial. So what else does uSampler appear? Yeah, they need to do the get uniform location of it, and they pass that too. Okay. But first, they activate it, presumably. Okay, so in the dwarf planet, yeah, the render the rainbow triangle, render the image of Pluto. We're not doing the this time seconds uniform anymore. Yeah. I wonder if like calling the uniform was also ruining it in some way. Zig build dwarf planet. Unused function parameter. Okay, we better use that. cd zig out, we already did that. Python and http sub. Okay. Still no changes, kind of like we suspect. Yeah. Still have stuff to do, so. Yeah, so we want to convert all of this stuff. So active texture, bind texture, and then the location. Active texture 0. Is that in the specification? It is. Another constant to look up and add. Of course. GL texture 0. Let's move it back up here. Okay. So here we want to do GL context.core active. Presumably this is the same. GL texture 0. Void. Yeah, it's a void passing the texture enum. Then we want to bind it. We already did this above, so we can just copy bind texture, copy that. Then the texture location we ought to do. Okay, so this we called it something else. Fragment shader. So here we called it. So like we call this like high P, but it's like these things are low P, right? We're like we're passing in F32, so like yeah, like if high P is like the six, like the, again, why do we have these like silly names? Like pi is something that describes like magnitude, but like a continuous magnitude. But if you're talking about like float 32 versus like 64, it's like there are better names. Anyway, maybe this was the bug. Anyway, so this is like uSampler, and so I guess here we need to replace texture 0 with uSampler. And then, and we're not using the color texture shader. Why do we still have color texture shader? We called it something else. What is the texture shader program? Okay, so then what's like the GL uniform 1i doing? Oh, that's just like update the uniform. Okay. So here we want to. Oh, there's a couple things going on. Okay. Get uniform location. We had something like this in like an older version. In either case, I think it's just another handle that we're getting. Yeah, it's an object, so it's a handle, and then it's the program, and then the DOM string name. Okay, so here we want to say constant, like texture, uSampler location, GL context.core, get uniform location, texture shader program, and then the string. Thanks for letting me know. So yeah, I don't know what to do. Like it seems to vary. Like it's just down to 1167. It sucks. I don't know like if it's OBS or like what it is. Why it's like, misbehaving so much. It's not like I'm running anything otherwise in the background that's graphically intensive. But thanks for letting me know. Sorry. Yeah. So yeah, texture shader program, and then it's like zjb.const string uSampler. And this is returning a handle. Okay. We've got that, so then we can update it. GL another context call. Is it uniform 1i? Yeah, uniform 1i. Oh, but here it's like like the location of the object and then int x. what is it doing? Okay, let's try compiling this. And then running it. Okay. Yeah, again, I'm getting this unsigned byte error. So it's so annoying. So annoying. So now we've like, I feel like it should be working now, and yet it's not. We could, one of the things that helped debug stuff last time was using an image that wasn't just black, because part of the Pluto image is obviously black. So we could try, just in case like this is actually rendering some pixels, who knows. If we replace the image that we're using with like this like RB, the one from like the test suite basically. Let's do file pilot. Yeah, where was it? .png search. Oh, there's like a lot of stuff. Way too much stuff. yeah, this one. Copy this. Yeah, we can now try just compiling it with this. No, compiling it with this. And then, okay, that. Not changing it. Like again, I'm trying to remember if we are meant to be passing like the 1 or the zeros in all of this stuff. If we replace the 480 with like the 1 again. Which way do we want to do it? What is Emacs doing? Okay. Yeah, let's just try this again. Is there any chance that we massively fudge these coordinates somehow? We're gonna have to deal with this. Okay. I wonder if this is actually, if this has been reported on the internet before, or if it's just us who was ridiculous enough to try to do this. Okay. So normally I just want to use a debugger and see, find out where this stuff is coming from. Don't know how to do it when we're doing stuff on the web. I don't want to like build Firefox from source and then like run that through. It could be possible. What to do? What to do? Okay, if I had to make a guess of what's failing, it's what? It's probably this tech image 2D. This is where the unsigned byte appears. So I guess we'll just look at tech image 2D again. Tech image 2D Mozilla. How are my frames dropping? Still terrible. Why is this failing? So what is this max type array view type? These names are just so silly. Max typed array view type. Okay, I guess it's this. Unless for this one we do actually need to I was gonna say call it to be 0, but I don't see why, given that in both cases we're specifying I wonder if it's like the vector stuff that's going on. Okay, this isn't actually just an array of U8s. Oh, the fact that this is a color here might be this might be stuffing it up. It's kind of incorrect to be calling this bytes. This really should be called pixels. Yeah, okay, so then yeah, we want to say Pluto pixel bytes with Pluto pixels. Okay, and then in this case, maybe we do actually want to take the first vector and then take the address of that. No, Stuart doesn't like it. Yeah, we might have to rethink this a bit. Oh, okay, yeah, so I guess when I was defining this to be a vector here in like x86, well, at least on most systems, everything is just going to get packed, and so things were working. What I was doing before with like the pointers and stuff was fine. Since this is like WASM, it's a bit different. So I think we're gonna have to like unpack this. We might have to like unpack this twice. So we might have to make this 4 times the Pluto width times the Pluto height. Make this undefined. And then when we decompress the image into that, temp sort of like test. Yeah, the way like the WASM like been dropped entirely. Sucks. Let's continue on. Well, if we're able to. Maybe we've just been completely wrong. Yeah, the way the WASM may store like vectors may be different. Yeah, let's put them into a like a kind of, let's say like the WASM may treat an array of vectors for U8 differently, like differently to a array of U8. So make a U8 instead. Get rid of this log stuff. Okay, so in this case, let's see. Oh wow, the frames are dropping again. Whatever. Let's see. Oh, if you erase, the frames are getting dropped hard. Maybe it's because I'm like downloading stuff from the stream manager. I wonder. Anyway, we're doing the U8 instead. So Pluto pixel bytes. Well, so we can say for Pluto pixels, for every pixel. Here we want to say 4 times I plus 0. Now I have to deal with like endianness and stuff. We'll get over it. Is equal to pixel 0. Like the main thing is just like rendering some kind of data on the screen. If it's like the wrong colors, we can figure that out. Blankness, not so good. Okay, we then do that, and then so now when we go down to Pluto pixels, pixel bytes, we kind of want that, and I think that's it. Okay, let's clear this again. Launch the server. No, it's still not working. Come on. What now? I thought I had completely cleared this. Right. This is so annoying. We probably should just like print out some of the data. So let's say we do log, and we print out the Pluto pixel bytes, like 0 to, I don't even know if the JavaScript bridge will handle this, but like 0 to 0 to 12. Let's just, oh, it's not, can it even do a byte? Oh, it can't. I guess we could bitcast it. This is kind of nasty, but okay. Let's just print out like the first couple. Let's just incast the first one. Okay, we're getting 255, which is what we expected. So that's reassuring. Dude, how are you meant to debug web stuff without, like, maybe there is a debugger, I just don't know of one. Certainly don't know how to do, like, stuff from within this WASM. I'm getting tired. What's the time? 8:30. But again, like, okay, let's try and find like this type. Why is like this thinking it's a max type array view type? Where's that even coming from? Like, is this anywhere on the internet? Although this is like in... Um, oh, this is like... Um, um, see, they're doing that. Oh, maybe it's like... Maybe it's more of the data view stuff. Yeah, I'm kind of lost. I'm really lost as to what to do from here on out. Yeah, I don't know what to do. This sucks. Yeah, I might just need to like sort of pause it here tonight and then over the coming days just think about what to do. Yeah, I'm at a loss. Like, like, is what we're doing so different? It's like, it's basically this stuff, is it not? Like, is it like almost like exactly this? We're just saying geotexture 2D, level 0, RGBA, the width and the height, 0, unsigned byte, pixel data object. Like, yeah, like, what else does it want? Wait, unless there's actually like a debugger in the browser, and so, if there's some way of like stepping through. Okay, it says there is. Anonymous code, whatever that is. Unless we can somehow pause on one of these. Okay, so all of, maybe this like data view is what we want. I've never like used any of this stuff before. This This doesn't feel like the right thing to do. Okay, maybe here's another idea. We kind of like give it we like specifically give it something like this, and then just like see if it's drawing it. How do we even go about that? Yeah, this might be the way forth. We like, how do we even do this? Array buffer view. Okay, what's this array buffer view? Maybe we haven't. Maybe going down this will help us. What is an array buffer view? The blob constructor. I don't see like array buffer view anywhere on the internet. It's like disappeared. Okay, yeah, generic raw binary data buffer. Okay. Let's just, yeah, we'll stop streaming but continue recording for a bit. So maybe this is why it's failing. It's saying that when we're saying unsigned byte, it's saying like, well, it has to be a U8 array, even though it like is. It's like something else. Okay, so then, okay, if we assume it's if we assume this is the issue, okay, how can we like cast the thing to this? We basically just want to. How do we do that? Maybe I'll ask Scott. Does this have like U into 8 array? Okay, so there is actually a U8 array view. I guess this is what we want to do. Okay. Okay, so how are we going to call this then? Okay, let's try this again. Okay, after this, maybe we will give it a pause. But this feels like progress. Okay, so we wanna call, and then we want to do zjb dot. Instead of doing like constant string or whatever, in this case we want to do the U8 array view. Okay, so let's try. So where are we? Oh yeah, this line fails. This, well, yeah. This line seems to cause a fail. Okay, so instead we'll do constant pixel data object zjb dot u8 array view. Now we take the Pluto pixel bytes, and now we'll try compiling with that. Build it, It's fine. Launch the server. Finally, finally. Oh my goodness. Okay, it's like, oh my goodness, finally. Let me just let the dopamine wash over me. We're gonna, I feel like I want to just listen to a reward song for getting here. Twitch probably won't be able to like, YouTube, I don't. Yeah, I'm gonna like, move on. We'll just, I really want to just like listen to something as a reward now. But, I suppose it's, we'll just push on. We'll push on. The reward will come later. Oh my goodness, that was quite something. So let's just immediately save this. I got. Okay. Okay, my goodness. That was so painful. But also too, like whoever at Mozilla like printed out that error message, like if it wasn't for that, it wasn't necessarily the best error message, but it did help us, and if it wasn't for that, probably we would have never debugged this. So error messages like that are so helpful. Okay. So let's get on to drawing Pluto again. So in the QOI, let's activate that again. We won't be needing that anymore. No, so let's compile it, launch it, and then it lifts my heart. So beautiful. Okay, we've done enough tonight. We've rendered Pluto. This is great. We can now, that was a mistake. We haven't rendered Pluto. We've rendered 134340 Pluto. Okay. And now that we've done that, 134340 Pluto. Let's just check the image is actually the correct way up. If we're even able to connect to the internet, which apparently we can't. Okay, it looks like it's upside down. Okay, so let's fix that. This no, stop at Windows. I want to make this window small, so we have it, so we know what the correct way up is. Actually, why am I even doing that? We have a very robust piece of software that will help us view this. It's called Zig Image Viewer by Jonathan Mahler and Dwarf Planet New Horizons QI. Okay. That's what we need to get it to. That's what it currently is. So let's like move that here. Okay. Guess we can zoom out. Okay. So we need to invert some of the directions. So I also want to try like not doing this stuff and to see if that works, but later. Okay, didn't want to do 480, so that was good. But here we want to invert the y's, so we want to replace every one in the final column. We want to replace everyone with a 0. It's probably easiest to do this manually. 0, 0, 1, 0, 1, 1. Okay. Zig build it. Launch it again. There we go. It's now rendering. Oh, that was one of the most painful things to try and debug, if you can even call it debugging. It was debugging. This year, easily the most painful thing. Okay. We did it, baby. We did it. Now I want to just see what happens with the vector stuff. So let's say we get rid of all of this, and we actually just keep the Pluto pixels as is. If when we convert it, are we allowed to convert the Pluto pixels to an array view? I suspect this will fail, but we'll see. Okay, not failing for that reason. Pluto pixels. Yeah, it is good. We do need to actually like convert this. Okay. Okay, so I guess this actually wasn't a possible bug. Like it was a bug, but for like a different reason. Okay, we absolutely need to have a. Wait, we should just this is to remain a note. Note. Node below. In the WebGL specification, assigned byte is commented out in pixel type. The constant still seems to work there. Okay, that's a thing, but we absolutely need to comment on the data view thing. We should also probably clean this up so we're not just like assigning a huge bunch of like we're basically like doubling the size of there are improvements to be made here with the Pluto pixel stuff. Yeah, we should say like to do. We might even need to like adjust the QI formatter so that it. Oh no, we should be able to cast it. Why don't we just do this now? No. The WASM might be doing stuff. But really, will the WASM? I feel like we should just be able to cast it. You can just say previously this is like. It's no, yeah, if I don't know the ABI for like the memory layout stuff, we'll just keep it for now. To do in order to pass a what is it? Was it like tech image? Yeah. In order to call gl.tech image 2D, to make a texture, the bytes need to be in a. It's like uint8 array. What even is it? One like is called this web page. Also, so I would say so without knowing how the like WASM will store vector for U8s, knowing if the WASM will store as like in the packed way on the desktop, a packed way as in x86. yeah, here we first decompress the .qi into an array of then convert it to a U8. It would be easy to modify the QI parser to decompress to directly output. Maybe we'll end up doing this. Convert it to but this is what we're doing for now. Okay, that's the thing, and then here we have to pass a like really important error message. Okay, get rid of this. That was all working. That's fine. That's fine. Okay. Very important. Geo.tech image 2D only like accepts only a pixel source only with type uint8 array. As such, applying a data view with the pixels will result in a fail. Will result in a in no texture like being drawn. Instead, use setjb.u8 array view. We spent something. How long even was this? Like 2 hours. Debugging this. We did get there though. Okay, but we did get there. So let's check that stuff is working. Is still working. After all those comments, Ziegler dwarf planet. That's fine. Launch the server. Okay, great. We can move on. Okay, that is enough for tonight. So, git status. Finally, like, yeah, successfully drew 134.34.0 Pluto. Yeah. So yeah, let's like get this. What's the time? It's like 9:20. I think we will clean this up next time. And yeah, next time will be exciting too, since probably Zig 14 will have been released. Is Zig 14 currently released? Let's see. It has been. Wow. Okay. The ultimate reward for drawing the moon up there. That we now have a completely new version of Zig. Of course, if you've been following the GitHub, etc., you know what's coming. But I need to refresh my mind of what's coming. So yeah, next time we'll be doing the README for 134.340 Pluto, and reading the new changes in Zig, then updating our sliding puzzle game to work with Zig 0.14.0 instead of the current weird dev release. And then if we can do that, this is actually gonna. We may as well just check this out now. This will depend on the game dev people making. We'll see. We'll see if this. We'll see next time if this compiles with Z14. But yeah, otherwise we finally got here. That was such a bad bug, my goodness. But yeah. Thanks everyone who dropped by or who are watching on the internet. See you next time. Bye.